All right, welcome, ladies and gentlemen, to 2.6, looking at vertical and horizontal translations, mostly in the graphs and things of the absolute value functions. So let's go ahead and get started. We're going to look at what's called a translation, and a translation is what's called a rigid motion operation that shifts a graph horizontally, vertically, or both, which we could call diagonally because if you go up and to the right, that's a diagonal motion. The word rigid or the word rigid motion means the graph stays the same shape and same size. So if I was to take this is not a graph, by the way, this is just if I was to take a square and then I was to use a rigid motion operation and I was to move it over here, the box would remain the same size and the same shape. That would be a rigid motion operation moving horizontally. All right, so we do this with graphs as well. And what we do is we take what's called the parent function. The parent function is the most basic function of a certain type. In our case today, we're going to look at the absolute value function mostly. And the absolute value function, this is the parent function. There are some things that we know about the parent function, like the vertex is at the point 0, 0. It has a slope of 1 on both sides, so it would be 1 on the one side and a negative 1 on the other side of that vertex. And it looks like a V shape. So we know that the graph looks something like this. Slope of 1 on both sides, vertex at 0, 0, or the origin, in other words. All right, and what we're going to be doing is we're going to take this absolute value function and we're going to be moving it left, right, up, or down, or a combination of both. So for vertical translations, this is what they're going to look like in your equation. We're going to have the absolute value of x just by itself, and we're going to have a plus or a minus k, where k is a positive number. If you have a plus sign in front of k, remember is just a number. If we had a plus k, that would mean we moved up k units. And if we had a minus, it moves us down k units. So if we were to look at an equation that looks like this, y equals the absolute value of x plus 3, it moves the parent function up 3 units, meaning it moves the vertex from 0, 0 up to 0, 3. So if we were to graph our parent function here, we would have a slope of 1 on either side. This is the parent function. So this is the parent function here in red. And if we were to move up 3 units to the point 0, 3, we would have our new function that looks exactly the same, just up 3 units from the original function. And notice every single point gets moved up 3 units. And then the other example here is if we have the absolute value of x minus 4, it moves the parent function down 4 units. So once again, it moves the vertex from 0, 0 to 0, negative 4. And if I was to graph that very quickly for us, we have the absolute value of x, the parent function, and then we're going to move down 4 units, and we have our new translated graph that's been translated down 4 units. I just wanted to write this in here. I know I've said it a couple times. Note the slope on either side of the vertex is 1 and -1, right? So we have -1 on the left here and +1 on the right. Horizontal translations is going to look like this, the absolute value of x minus h, where again, h is a positive number. And in this particular case, it moves in the opposite direction you would think because it's inside the absolute value. So if it's a plus h, it moves to the left. And if it's a minus, it moves to the right. So in this first example, the absolute value of x plus 3 moves the parent function 3 units to the left. So it would change our vertex from 0, 0 to -3, 0. Now, when you are graphing absolute value or graphing these functions, you do not need to graph the parent function as well, but I'm using the parent function to really emphasize the idea that it's moving 3 units to the left. So there's our parent function again. Parent function I'm going to be graphing in red. And 3 units to the left is going to look like this. And there we have our translated absolute value function, 3 units to the left. And let's take a look at one that moves to the right. We have the absolute value of x minus 4. Moves the parent function 4 units to the right. Moves from the vertex from 0, 0 to the point 4, 0. And if I was to do a quick sketch of this graph, we're going to move to the right 4 units. If we were to graph our parent function again, parent function vertex at 0, 0, slope of 1 on either side. And then 4 units to the right is our new function. All right, so now we have the basics. We have the vertical and we have the horizontal translations. Let's go ahead and look what happens or what they're going to look like if we combine them together. So this is a combination of vertical and horizontal translations. It's going to look like this because we're the same idea as we had before. The h moves left and right and the k moves up and down. And what this is going to do is it's going to move the vertex from the coordinate 0, 0 to the new coordinate h, comma, k. So if we had this equation, we have to put everything together that we just learned on the last 2 slides, where the -7 on the outside moves down 7 units, and the +4 on the inside of the absolute value is going to move us left 4 units. So we can say that this transformation or translation is left 4 and down 7. So it's going to take my vertex, or our vertex, and it's going to move from the point 0, 0, and it's going to move to the point -4, -7. So if I was to go -4 to the left and -7 down, and then if I was to do a quick sketch of the parent function, note that the parent function is at 0, 0, and the new vertex is down here at -4, -7. Oops, I changed color on that one. -4, -7. And we would graph thusly. And there we have the transformed graph. Yes, we can use fractions, but it works exactly the same. The plus on the outside means move up 3/4 of a unit. The minus half on the inside tells me to move right 1/2. So our translation would be described as right 1/2 and up 3/4, moving the vertex from 0, 0 to 1/2, 3/4. And it would look something like this if I was to draw in my parent. And then if I was to go to the coordinate 1 and 1, obviously we're not going to 1, 1, but we are going to, let's see where this is going to be. If this is half and this is half, we're going to go half to the right and 3/4 up. So that's going to be my new vertex. And we're going to be parallel to either side of the absolute value function. And there we have our transformed graph. This actually kind of finishes us off today, but what I really want to point out is I used all positive absolute values here, but it works the same for absolute value, the negative absolute values. We can write equations where it's negative absolute value of x plus 3 minus 7, where it's now the parent function is the negative absolute value of x. So you want to remember that the negative absolute value of x, and let's not do that one, let's do this line. The negative absolute value of x looks like this. It's just same thing at 0, 0, but goes downwards on both sides. And this is still going to go left 3 units and down 7. So I'm going to be left 3 and down 7. I know that doesn't really look like this, but just as a quick idea here, left 3, down 7, and then we get a graph that looks kind of like this. So it still works with the negative absolute values, and it will work with, actually eventually we'll be looking at every type of function that we're going to look at has these type of translations. But right now we're just specifically looking at the absolute value. Last note that I want to make is we can talk about linear functions that are non-absolute value function. We can say like y equals x. Y equals x is our parent function for linear functions. So if I was to graph the line y equals x, it would look like this, has a slope of 1, goes through the origin. But I can then write a transformation where I say y equals x plus 2. And this is really a translation. Yes, some of us understand that this is the y-intercept and the slope is still 1. But what this really is a translation up 2 units because it's the plus 2 on the outside of the x. So we can write this, or we can draw this, as a translation moving up 2 units. All right, so that's going to finish us off for today. I hope you guys learned a little bit, and I will see you guys later.